Amidst the expansion and consolidation of the fourth industrial revolution, responsible for popularizing intelligent and automated systems in the means of production, measures are also being taken to combat environmental degradation and waste of natural resources. These factors provoke a revolution in the organizational engineering of industries, now preoccupied not only with profitability and mass production, but with the management of high technology as an instrument of strategy and project organization, in addition to constant concern for sustainable and innovative development. In this revolutionary context, the Internet of Things is emerging as a green technology, focused on sustainable and promising industrial growth. Internet of Things refers to the integration of the ability to connect the Internet to everyday devices. With this, any device becomes capable of transmitting and receiving data, making tasks such as home automation a reality closer each day. With IoT networks, activities like controlling a domestic air conditioner or even bedroom lights are possible from anywhere, anytime. Analogously, in the industrial environment, the application of this concept have a great potential in the optimization of processes, allowing innovations in areas ranging from diagnostics, through sensors built into machines, to production control, as machines become capable of reporting their status in real time. The Internet of Things is designed to describe a range of technologies and research that enable global connectivity between physical objects throughout the world, enabling technologies like RFID, sensor networks, biometrics, and nanotechnology are becoming very common, taking IoT to real-world implementations, addressing a variety of applications including smart grid, e-health, and intelligent transportation. They foreshadow a promising future that closely interconnects our physical world through sustainable networks. Green networks at IoT, GIoT, will contribute to reducing emissions and pollution, exploiting environmental conservation and surveillance, and minimizing operating costs and energy consumption. The GIoT is expected to produce significant changes to our daily lives and help us realize the vision of green environmental intelligence. In order to verify the growth in the field of academic research of the Internet of Things as a means of sustainable development focused on information systems, organizational engineering, and one of the transformational functions of production engineering, according to INAD, this work proposed the bibliometric search of terms related to this subject in the Web of Science platform. The notion of bibliometrics was proposed in the late 1960s as the application of statistical and mathematical methods in the analysis of literary works. Pritchard, 1969. Thus, the bibliometric search aims to analyze the production of articles in a certain area of knowledge. In the context proposed in this article, said area is the Internet of Things, aiming at identifying possible networks of knowledge and trends in the current academic scenario. The Web of Science platform is a world-renowned portal in the academic world that has a large database and is ideal for conducting reliable bibliometric analysis through tools for citation, reference, and H-index analysis. Thus, CC covers approximately 12,000 journals and allows for the consultation of 5 collections. This was used as a source of the bibliometric search suggested here. The bibliometric search was carried out from searches with the keywords related to the subject of study. In order to achieve the expected results in the objective of this work, terms were used that encompass the concentration areas chosen for each of the engineering assignments assigned to the group, computer engineering and network engineering, and terms that encompass the proposed subjects analyzed: sustainability, innovation, information systems, and more specifically, Internet of Things. Using these keywords in English in the terms sustainability, innovation, information systems, and Internet of Things, the bibliometric search was performed using the standard syntax used by Web of Science. The syntax consists in the use of Boolean operators such as AND and OR, and similarity functions such as near, to perform the crossing of terms for the chosen themes. In the advanced search section of the Web of Science, you can determine the search period. For this article, in order to have a better understanding of the interconnection of the elements analyzed in the last years, a limit for the publication of the articles was defined. Thus, references were searched for the last 9 years. That is, the search is comprised of articles from 2010 until today, 2019. The results were also filtered against the Web of Science categories, choosing the areas related to courses in computer engineering and network engineering. It is important to note that in Web of Science there is a large fragmentation of the areas of computer science compared to others, with at least 6 subcategories having to be selected in order to achieve the desired results. The following categories were selected: electronic electrical engineering, telecommunications, computer science artificial intelligence, computer science hardware architecture, computer science theoretical methods, computer science interdisciplinary applications, computer science information systems, and computer science software engineering. In order to get relevant results to our research, we analyzed only the output graphs related to the areas of research of the articles, as well as the years and countries of their publication. The first search performed between the keywords of each engineering and the term innovation returned around 900 results, showing a good response to the innovation articles in these areas. The second one, the search regarding sustainability, returned around 3,000 occurrences, revealing great connection between engineering and sustainable development issues. In order to analyze the relationship of computer engineering and network engineering with production engineering through the item information systems, defined by INAD as A2, the third bibliometric search was carried out. As a result, around 3,300 occurrences were obtained. Researching the relationship between engineering and innovation and sustainability topics, around 60 references were found, showing difficulty in introducing one more variable. The search made to verify the proximity of Internet of Things with areas of innovation and sustainability returned 52 results, and showed that the theme has a certain niche in the academic environment. Finally, the bibliometric search was carried out looking for connections between computer engineering, network engineering, and the Internet of Things, obtaining around 1,100 occurrences. Overall, the results show the prevalence of researches in electrical electronic engineering, followed by telecommunications and the various areas of computer science. The number of articles per year of publication showed a growth trend that was common until 2016-2017, with a subsequent fall. Finally, the number of articles per country showed a strong presence of the USA and China as leaders.